Hello and welcome to this presentation about performance tuning for PowerBuilder. In today's session, we will start by explaining why this feature would be helpful for you. We will also mention a couple of use cases. We will explain how it works. We will see that in action with a sample application. And finally, we will address potential questions you may have. A word about the company. We are Novalis, developing tools for PowerBuilder and .NET developer to help them maintain, improve, and secure their code. The company was founded a while back. We have now customers in more than 80 countries. And we recently released tools and features to implement continuous code inspection, to implement advanced security for PowerServer application, in particular PowerServer 2021 and 2022. To implement multi-factor authentication, MFA, for PowerBuilder, and to integrate PowerBuilder application with Okta, an identity service provider. So why did we develop this feature? Basically, it's meant to go beyond the traditional PowerBuilder tracing and profiling that you probably know. We will first collect and consolidate traces coming from multiple sessions and workstations together. You will then visually analyze this result and identify easily the bottlenecks across a large application or large volumes of code. It will basically look like this, but we will see that in more detail when we will do some clicking a bit later. We will extract the top slowest object in your application and put them in a container hierarchy so that you can see where they are located in your code. With a large application, chances are you will come up with a long list of objects that need some refactoring. So the key question is how to prioritize. Which object should I work on first to gain the maximum benefit for every minute I will spend on this particular task? To help you with that, we provide two angles to analyze the result. First of all, you will be able to see the average execution time, which means basically we will show you which object or methods are taking the longest time when the application is running. And that does not take into account how frequently these objects are executed. It's just that they're taking a lot of time. And the second angle is what we call cumulated execution time. This one is taking into account how frequently this method or object was executed. So we'll basically multiply the average execution time by the number of executions to show which methods are consuming the most resources or consuming the largest number of minutes in the user experience. And by combining those two angles, you will be able to identify priorities. And I will show you an example of that when we will do the clicking, why it is important to check under these two angles. The second aspect I would like to outline today is that the analysis scope is flexible. Basically, depending on the perimeter you need to review, you can analyze performance for the entire application, but if that's very large, maybe that's not appropriate. Sometimes you may need to focus on a particular PBL or library or some specific type of object. For example, review all the windows or user object, or you can focus on a certain selection of object that needs to be improved. Let's see now a couple of typical use cases. First of all, you may want to perform a general review of the application just to generally improve the response time. The point is, it's difficult to know where to start with a large application, so we want here to identify the main bottlenecks in the whole application. And that comes down to prioritizing the object or methods that needs to be improved. The second typical use case is you may have to improve certain feature of the application, in particular in the case of user feedback. Can have a user saying, anytime I'm clicking on this button, there's something going on in the background that is taking too long. Can you please improve that? And quite often, some complex feature in the application involve a long chain of calls, functions calling each other or object calling object, etc. So here, what we will do with Visual Expert is get a visual representation of the call graph with the execution time for each node inside the call graph. Then you can pinpoint and identify the slowest piece of code. This is something we will see right away during the clicking. Now, let me explain quickly how this is working. First of all, we need to collect data. So you will basically add a PBL in your application that will generate a trace file anytime there's a new session going, which means if you have several workstations generating the data, you will collect several files for each session and or workstation. These trace files will contain statistical data on the execution of the application object. This data will allow Visual Expert to analyze its performance and show you visually what's going on and what's taking time. All the files will be stored in a common folder for Visual Expert to find them and include them in its analysis process later on. And this is where we go to step 2, analyzing and visualizing the data. So when you create your Visual Expert project, you will include the folder containing the trace files on top of the source code of your application that you usually analyze with Visual Expert. Then the code parser reading the source code will also take into account the trace file and will combine these two sources of information. That will enrich the description of the application structure with information on its performance. Now, let's see that in action with Visual Expert. Let's start with a quick overview of the UI in case you're not yet familiar with Visual Expert. So on this part, you would see a dashboard with code inspection result where you can analyze security issues or maintainability problems or bugs. In this part, you will see the application at component level. For instance, a PBL, a window containing controls and methods. Anytime there's some code to display, it will display right here. And on the left-hand side, you will have what is called a navigation bar with a list of features. You can see that as queries, question you can ask to Visual Expert regarding the current selection. And as you can see, this list is different depending on the type of item selected. So for a window, we have this. A data window, there's another list, PBL, etc. And all these features are grouped into this group here that you can fold and fold depending on what's interesting for us. And today we will focus on performance analysis. So for starter, let's take a look at the slowest component across the entire application. So I can select the root of the PBL that would include all the libraries and check for the slowest code. And the results are displayed in the tree view with the methods, in that case, with the longest average execution time. And they are placed, as you can see, in a container hierarchy. So for example, I have a click event here that is included in this menu item, this menu, this library, and this application. And for now, there's only the top 10 slowest object, but I can change the size of this list by using this parameter here. I can ask for 20, the 20 top slowest object, or come back to 10. And I can even ask to display object with a certain minimum execution time. 5 milliseconds, 10 milliseconds, you name it. In case shorter time is not relevant for you, you can just focus on what is exceeding your limit. So you can adjust the size of the result. But as we mentioned before, you can also adjust the scope of this search. So instead of searching across the entire application, I can just select one library and do the same. In that case, I have the top 10 slowest object or methods in that particular PBL. And if needed, I can focus on one or several specific objects. I can pick this window, for example, and with the Control key, select another one and do the same. In that case, I have a list of the top slowest methods for each of the selected objects. For now, I've been analyzing performance on the PowerBuilder code only, but actually I can do the same on the database code as well if I included this code in the Visual Expert project. And that works for both SQL Server or Oracle. The concept is the same. I can select a certain scope, for example, the stored procedure, and display the top slowest object for that particular scope. In that case, a list of stored procedure sorted by average execution time. And again, by using this parameter, I can adjust the size of the list. Now, if you remember, I mentioned that we can analyze performance under two different angles. The average execution time, that's what we just did, but also the cumulated execution time, that is taking into account the number of execution for each object. In other words, maybe you're not interested in improving the top slowest object if it's rarely used. Maybe there's another object that is not as slow as this one, but it's executed so often that overall it's really hurting the user experience. So let's see how this works. Basically, you do exactly the same at PBL root level or object level. Any scope is the same. And instead of using the slowest code feature, you would go for the cumulated execution time. And in that case, you also have a short list. You can adjust the size of this list, but it's for each object, the average execution time multiplied by the number of execution. Now let's take an example to illustrate why it's important to look under those two different angles. I will take the example of a certain object. Let's select this window and look at the slowest methods behind this window. As you can see here, the champion is the click event of the button CB1. Now I want to compare this list of the slowest code with the cumulated execution time. So to do that, I will detach this portion of the tree view in a separate panel and open the second list, and then you will be able to compare. So for that, I can right-click, create what we call a view, which is a tab for this particular selection. Let me resize it a bit to make it easier to compare. Okay, like that. And right now here, instead of the slowest code, I will use the cumulated. So I have the same window, but a different result. And in that case, as you can see, the champion is the click event of the button cancel. And why is that? Probably because it has been executed a large number of times. Because right here, this one was not so obvious. So even if this one is not taking so long, if I can maybe divide by 2 the execution of the code behind it, I will save a lot of time for this particular window. And I can double check the number of execution to make sure there's no misunderstanding. So let's detach this one as well. And here I can see what are the most executed objects in this window. And obviously this one is frequently executed. This is why it's in average consuming so much time of the user experience, whereas the execution time itself was not so bad. In terms of priorities, I should probably for this window focus on this method and this one. This is an example of why it's important to use both angles to detect those priorities. Now let's focus on this use case where we want to improve a certain feature of the application after a user feedback explaining that it's taking too much time. So we will analyze the chain of code behind the event corresponding to the user action in the application and see for each node of the chain of code what's happening. I can come back to the same window we used before. And let's say that this is the event corresponding to the user action. And this is after clicking on this button that the user is complaining about the response time. I can go to the performance analysis section of the navigation bar. And this time I will click on this feature. And this will show the whole graph that is executed after the click event of this button. So this event is calling another event that is calling a function. This function is executing a stored procedure. So you see this is SQL Server code in that case, database code. This stored procedure is containing a select that is also executing another database function. And for each step of the way, you have the average response time. So this is a very small chain of code. you don't need a tool to analyze this. You can just look at the code and jump to, node number 2, 3, 4. That's it. You've been reviewing the entire chain of code. Let's take real life, real complex cases. So instead of this event, let's see what's happening with this one. So again, performance analysis and call graph execution time. And now I have a real life example where PowerBuilder methods are calling each other. So you see this one is calling this one, which is calling this one, and all the way down for maybe 100 different calls. That would take much more time even to draw up the chain of call, not even mentioning analyzing where the time is lost. But visually here, you can see that this is the champion, taking much more time than all the other ones. Let's take another example, this time with this event. The call graph here is a bit more complex, not so big, but still, where you have an event calling a data window. The data window is triggering a stored procedure with an execute statement, executing another procedure with a delete statement, executing a foreign key. The foreign key is eventually executing a trigger with an execute statement itself calling another stored procedure, inserting in a certain table and executing this database function. And here again, in every step of the way, you have the average execution time and you can pinpoint easily which one is taking more time. The last example we will demonstrate today for tuning the performance of your application is related to another use case. Imagine the DBA who's monitoring constantly the database finds a particular SQL that is slowing down the database itself. He would send back to the development team this SQL, but there's no way to know where the SQL is coming from, which object with method has generated this SQL. This is how we can help with Visual Expert. First of all, you would select a table. Let's take the customer table here. Then you can ask to see the slowest SQL accessing this table. And again, you can select here how many of them you want to see. They're sorted by average execution time again. And there's an easy way here to know where this is coming from. You can simply locate this item in the hierarchy of your application's component. In that case, it's coming from a stored procedure contained in the database schema called data. And you can do the same with other items generating a slow response time or consuming resources from the database side. And for all of them, you can see where they're coming from. This concludes our demonstration about performance tuning for PowerBuilder using Visual Expert. Thank you for watching this presentation. I think we have time for question and answers. Please, if you have some question about this presentation, just let me know. I'll be glad to answer.